Hi, 8th grade. This is video 3 of lesson 8.6, and this is also going to be the first video of part 2 where we're dealing with word problems. Now we're going to be looking at 3 different types of word problems for rational functions. The trickiest part, in my opinion, is just deciding, is this going to be a proportion? Is this going to be 3 fractions working together? Solving them is going to be the same as what you did in the first 2 videos. Setting them up, you have to get organized and have a plan. Now, if you're following along in your textbook, which I don't have with me at the moment, that has tables and charts where they organize the thought process for you. I did draw some of those into these notes to help you get organized, and I'll do the best I can to help explain why one might be a proportion and one would not. But if you need more help with that, don't forget to check out Connect Ed. There's videos on there that are useful with setting these up. Okay, so we have a definition to start with, and you may or may not actually use this definition when you're going through this chapter, but this is a common expression that you will hear, and it's weighted average. So whenever we're talking about your GPAs for high school, those are going to be weighted averages. So a weighted average is a method for finding the mean or average of a set of numbers in which some elements of the set may carry more importance or weigh more than others. So this idea is included in many applications involving mixtures, work distance, and interest. Okay, so if you hear that expression of weighted average, that's essentially what we're doing in these videos with these word problems. So starting with guided practice 3. Guided practice 3 is a mixture problem, and we know it's a mixture problem because it's involving percentages here and a solution. So Jimmy adds a 65% fruit juice solution to 15 milliliters of a drink that is already 10% fruit juice. So he has already 15 milliliters of a drink that contains 10% juice. So actually, I'm going to go ahead and start pointing you into this direction here of us setting it up. We have a total of 15 milliliters, and of that, we have a certain amount that is the 10% juice. How much of the 65% fruit juice solution must be added to create a fruit punch that is 35% fruit juice total? So we have a drink that's already 10% juice. We want to add a substance that contains 65% juice so that it balances out, isn't the word, so that it mixes to become a 35% fruit punch. So we have the 15 milliliters of the 10% juice out of the 15 milliliters total, and we're going to add, I chose X amount of milliliters of the 65% fruit juice. And obviously, if we're adding X amount of the 65%, then we're adding X amount to its total. Now, if that doesn't quite make sense there, maybe this part will. We have of the 15 milliliters, we're going to add some more. That's our total solution. The percentages are going to go across the top. So the 10% in the 15 milliliter solution plus how much of the 65% solution, and we want that to equal out to 35% or 35 over 100. So any type of mixture problem where you have a substance and you're adding something to it, you're going to form a proportion here. So again, I'm going to walk through that one more time. The denominator is the total amount of the entire juice, I guess, is 15 milliliters plus whatever we add. Well, in that 15 milliliters, 10% is juice, plus whatever we add is 65% juice. And we want that to equal out to a 35% juice, 35 out of 100. Now we have a proportion. We can't just ignore numerators and denominators here. We are going to need to do cross multiplication. So we have that on the next page here. So I cleaned it up. 10% of 15 is 1.5. 65% of X is 0.65X. If you want, you could reduce this. I just went ahead and left it And then we cross multiply. So 100 times our numerator up here, 35 times our denominator down here. Distribute 100 on the left, distribute 35 on the right. Combine like terms, subtract 35x, subtract 150, divide. Then we would have to add 12.5 milliliters of that 65% solution in order for it to mix with the 10% solution and create a 35% solution. So that's how mixture problems work. Ignore this up here. This goes with something down below. So that's guided practice 3. And I'm actually going to stop this video, give you a chance to process, and you can move on to the next video when you're ready.